Right now we can't subtract because one of them has square root of 27 and one of them has square root of 3. This is like 4x minus 3y. There's nothing you can do. They're not like terms. But if we simplify this, possibly we will get something that's like terms. And so the thing to do is to do the prime factorization of 27. It's 9 times 3, which is 3 times 3 times 3. So we have that 4 times the square root of 27 is 4 times the square root of 3 times the square root of 3 times the square root of 3 minus 3 times the square root of 3. Now that is 3. So we have 4 times 3 times the square root of 3 minus 3 times the square root of 3. Lots of 3's. So we have 12 square roots of 3 minus 3 square roots of 3. And this is like 12x minus 3x. And we know that's 9x's. So in the same way, 12 times the square root of 3 minus 3 times the square root of 3 is 9 square roots of 3. And we're done. Here we need to multiply each of these two times each of these two. You can call it FOIL, you can call it whatever you want, but that's what we need to do. 2 times 2 is 4. Here we're getting plus 2 times the square root of 3. Here we're getting minus 2 times the square root of 3. And here we're getting minus the square root of 3 times the square root of 3. That is 4 plus, that is 0 minus, and the square root of 3 times the square root of 3 is 3. 4 take away 3 is 1. So when you multiply these two quantities, you get exactly 1. That means, in a sense, that these two are reciprocals of each other, which kind of boggles the mind. Because when two numbers multiply together to give you 1, by definition, they have to be reciprocal. Don't try to distribute the 2 to the 4 and the square root of 7. You can't distribute an exponent across an addition. You can't do it. Instead, the best thing to do is to turn it into a problem like the previous one by writing down what it means to square a binomial. It means to multiply it by itself, and there's going to be 4 terms. There's going to be 4 times 4, or 16. There's going to be plus 4 times the square root of 7. There's going to be plus another 4 times the square root of 7. And here, square root of 7 times square root of 7 is merely 7. So we have 16 plus 7, which is 23. And we have 4 of these plus 4 more of them. That's 8 of them. 8 of the square roots of 7. And we're done. For us to simplify this by rationalizing the denominator, which means make the denominator be a natural number like 5, 7, or 12 with no roots in it. This kind of problem will be on our exam for sure, and you really have to make an effort to learn what to do. People who just kind of rely on sort of knowing very seldom get this right. The trick is, what do you have to multiply this bottom by to make this new denominator just be a regular number? And it's very sneaky. In essence, it has to be almost exactly this. But if you put a plus sign here, then the middle terms won't disappear. So you have to put the opposite sign. So we have a 6 and we have a square root of 3, but here we have a plus, here we have a minus, and that's going to make those middle terms cancel. What we multiply the bottom by because we need to. We multiply the top by because that's what we have to do. So now on the bottom, the 6 times the 6 is 36. But see, here we have positive 6 times the square root of 3. Here we have minus 6 times the square root of 3, and those cancel each other. That's why we picked this conjugate in the first place. And then lastly, we have this times this. A positive times a negative is a negative, and square root of 3 times the square root of 3 is 3. Looking ahead, because I can't help myself, it looks like we're going to have 33 in the denominator, which is rationalized. It's written as a regular number. On the top, you get any old kind of junk that you get. Oftentimes, it's just 4 separate terms that don't even match each other at all. So here we have a 12. Here we have minus 2 square roots of 3. Here we have plus 6 square roots of 5. And here we have a minus, and they're both little leftover pieces, so we put them in one leftover container. And sure enough, there isn't anything that collects together. They're just all separate terms. It's sort of ugly. So we have 12 minus 2 square root of 3 plus 6 times the square root of 5 minus the square root of 15 all over 33. And that's our final answer.